going to have you line up with your ankles touching, so you're at a comfortable, are you comfortable the way you're standing? Mm-hmm. All right, so I want you to just look at a spot on the wall, pick a spot on the wall, and I want you to stand still. And we just need to observe to see how well she's balanced, okay? Now, we're going to have her close her eyes, okay? And we're going to watch and see if she has any body movement. And we're going to compare those two. Okay, that's the simple instructions. So the way to explain this, because we've never done this one before, okay, we have two things that are going to allow us to do balance as a reflex. Okay, we have the vestibular apparatus, okay, and then we also have the muscle, spindle, and Golgi tendon organs. Okay, so let's talk about muscle, spindles, and Golgi tendon, because you guys have already talked about those a little bit. The thing with those is they do sense stretch. We talked about them with the proprioceptors, but they're most responsive to really rapid stretching. Okay, I mean, one of their jobs is to help us do 3D space, but it's also to avoid injury. So if you have really rapid changes, you're going to have changes in action potential frequency. If you stretch those slowly, you get a change in action potential frequency, but the brain is not going to respond to it very much because we have minute changes in muscle link all the time. So you have to have a pretty substantial stretch for that to be a significant input in this reflex. The thing that is going to affect how well she balances is how attuned she is in her vestibular apparatus. Okay, so within there we have the saccule and the cupula. So we have areas in the vestibular apparatus where you have, you know, the big. Okay, this is a kind of a cool thing, and you can demonstrate this with the students. This is the cochlea where the hearing apparatus is. This is the vestibular apparatus. So if you think about where this is in the head, the position of it. Okay, I'm going to line this up like it's in my head, all right? So the vestibular cochlear nerve goes towards my nose when I hold it up, okay? Now notice you've got 3 semicircular canals in different planes. Each one of these are filled with fluid, and down at the base you have hair cells that respond to acceleration. So first thing you have to do is you have to accelerate enough to get the fluid moving. Okay, so what you'll see when the eyes are closed, and I think we'll actually switch the directions, remind me to do this. We'll switch the directions to where they do it with their eyes closed first and then with their eyes open. With their eyes closed, if they stand there long enough, you'll see them move, but they catch themselves. The thing about it is that they have to move quite a bit to accelerate the fluid in the vestibular apparatus enough that they'll perceive it. So you'll see them adjust, but you'll see them move a couple. So it depends on how attuned they are. If you have a dancer or an athlete, they probably won't move a whole lot because they do they're really sensitive with their vestibular apparatus. But some people, like me, aren't that good at balance, and you'll see them move significantly. And the idea here is that you have to have enough acceleration in a direction to get the vestibular going, or your muscle spindle is activated. Okay? We want to focus on the vestibular in this, though. Now, when you're looking at something and your eyes are open, now you have a different sensory input that your brain can interpret. And you're going to be able to notice if you move, your brain's going to sense if the image is moving before you accelerate your vestibular apparatus. So when your eyes are open, your sight is combined with the vestibular. Okay? When your eyes are closed, it's called the vestibular ocular reflex, by the way. But when your eyes are closed, you'll see more movement because you have to get this end of lymph moving.